Please welcome Mads Torgersen and Dustin Campbell.
Hey! How are you doing?
Hello.
How are you doing? Woo!
Come on, guys. I know it's 4:30 and everything, but it's time and the sugar rush from earlier has gone down. But one more time. Hello! Yeah!
Look at these shirts.
Yeah.
We're so happy that Microsoft has finally joined Xamarin. This is awesome. So let's introduce ourselves. I'm Mads Torgersen. I work on the C# team. I run the language design for C#.
My name is Dustin Campbell, and I'm also on the C# team. Been working on Roslyn for a number of years, and also my main focus is on the editing experience in the IDE.
So there are other people than you that love C#. Stack Overflow did a survey like they do every year of their users. Might not be completely representative, but we like it because what we see here is that C# already has a lot of users, right? And we are only about to make that better as we're coming together, Xamarin and Microsoft. So C# is a pretty popular language, despite the limitations there have been historically and where it runs. It's also, if you look at their most loved technologies, which is the languages or technologies that people use that they would like to continue to use, we're actually on there as well. We're a little further down, but we're still in the top 10. So we're one of a very select group of languages that are both very highly used and very highly loved. And we really appreciate that, and we think we have a lot of opportunity with that. It's also, I mean, you can kind of notice that the languages on top here are languages maybe with smaller followings that are very dedicated, some of them growing. And we're really happy to see F# actually near the top there as well. So a very nice place to start, and a very big opportunity for us to grow. And so the way that our team is considering contributing to that is mainly through two things that we've been doing for many years already, which is essentially language evolution, keep that language fresh, make sure that we are boldly, but hopefully tastefully going into the future, adding features so that it's still an attractive language to choose for someone wanting to solve today's problems, and remains so, right? And the other pillar of it is that we've always been very focused on the tooling, all the way back from before .NET, really, with VB, where the quality of the tooling, the sense that it understands your program, has always been a focus for us, and we also want to continue to push on that. Used to be very focused specifically on Visual Studio, and in later years we've been very focused sort of on toolability in a more broad sense.
Yeah. I mean, that's kind of what a big piece of what Roslyn was, right? Yeah.
You say Roslyn.
I say Roslyn. You're right. So Roslyn, we shipped version 1.0 of Roslyn last July with Visual Studio 2015. It was a big milestone for us. I had worked on that for about 20% of my life. It took a while to get done, but we got done. And now we're kind of looking ahead to see what we want Roslyn to become. And if you're not familiar with Roslyn, I think most people here are familiar with Roslyn because now it's driving Xamarin Studio 6 IDE tooling as well. And that kind of goes into what we want to do with that. We want to see Roslyn become the C# and VB language engine for everything, for all the things that are about C# especially, right? So that means all the editors and IDEs, everything, every kind of tool like a linter or an analyzer, any kind of static analysis, fixes and refactorings, all those sorts of tools, and REPLs and interactive and scripting and all those things. We want to see Roslyn at the heart of that. There doesn't need to be several half dozen, C# code bases that try and keep up with the C# language. Instead, take the C# compiler, the one we built, and use that at the heart of all of these tools so that we can get a great consistent experience across all these tools. You should be able to walk up to any editor, whether it's Xamarin Studio, Visual Studio, whether it's Visual Studio Code, whether it's Sublime Text or Atom or Vim. Emacs, any of those, and you should be able to get an experience from C#, or at least that's consistent with that host editing experience, but also gives you the consistent data, from the tooling, the feedback in your editing experience. So that's where we're kind of looking right now and what we want to do with it. So I'm going to show some stuff there that we're doing. But But that's not the most interesting thing to these guys, I'm pretty sure. They really want to be here to talk about C#.
They like it all. We have a couple of things on the menu. We're going to talk about C# 7 because there's always the next one. Then Dustin is going to talk about our integration with VS Code some, but also this notion of the inner loop and how we're trying to improve the inner loop of the development experience. So without further ado, I will go and leave this slideshow behind, go into something called Visual Studio. How many people in here use Visual Studio? OK. These features should be coming to other editors near you, including Xamarin Studio, as we actually finish them. So I have some very rough, smoking hot bits here that actually you can't get yet. I do want to say that we're working hard to actually make it so that we can very easily ship prototypes. So far for Visual Studio, but hopefully other platforms in the future where it's easy for us to ship in a NuGet package or a v6 or whatever, ship a prototype of compiler and IDE behavior, and you can just go and use it and turn it off when you don't want to try it anymore, and give us a bunch of feedback. But we're not quite there yet, but I have the bits here on my machine, so I'm the lucky one. So I'm going to show you some of the features we're thinking about for C# 7, which is targeted to come out with the next version at the same time as the next version of Visual Studio. I'm going to start with some small ones just to get us warmed up. So let's get a little int array here. Let's put some numbers in. Let's do the powers of 2. Let's see. It gets harder to remember when you get older.
So Max, hold on. What is this project?
What?
I thought we talked about doing mobile apps.
Mobile apps? Oh, this is
Evolve.
This is a console app. Oh. A console is this other kind of device that
I see.
A lot of people actually use in the real world. Wow, that was a low dig.
Yeah.
OK. No, so now I totally lost my flow here. I was writing powers of 2, and I think it would actually be better to do it in binary. So one of the little things that we've added to C# is binary literals. There are people who want to use them, but now it's very easy to kind of lose count of the zeros here. So I want to use my new digit separators as well that you can stick into your longer constants. It's OK to clap. There was one guy who they couldn't contain themselves. I know this isn't the big stuff here, but yeah, it's OK. Go for it. Right? You can put these underbars wherever you want. If I want to separate them every other one, I can do that. I can put like 7 if I want to. It's fine. You can do whatever you want, really. We're not judgmental. It's the new Microsoft. Many underbars as you like. So that was just like warming up here. So let me write a method now to. I want to take an array such as that one. Let's say IEnumerable of int, and I want to add them up, and I also want to count them.
Matt, is that a new keyword? Static.
Yes.
Static.
Yes, it's a new keyword. Thank you. What would I do without you here on stage? Yeah, this is inside. I don't want to do this just yet. Let's take this and put it in its right place. So I almost showed you another feature there. We'll get to that later. So here's a static method. What should it return? It's going to sum up the numbers. It's also going to count them. Should it return the sum or the count, like any ideas? I think we should return both. So let's return a tuple.
Ooh.
Yeah. So this is a little tuple type. So let's just for now do a dummy implementation where we return. This is a tuple literal. Let's just return 0,0. That kind of looks nice, doesn't it? And then let's go up to this horribly formatted method here and call it. So let's take the result of that tally call there, or that tally method, call it on our numbers, and let's see what it returns. I have some horrible tooltips here because this is a prototype. They'll look nice and syntaxy. But what you can see, it does indeed return a tuple. The tuple has something called item 1 and item 2 in there. Let's see what that means. Let's print it out. Right line of, let's see. Let's take the sum first. That is probably, the sum is probably item 1. So let's say t dot item 1. So this is a way that I can get at the values, but it may not be ideal. So there are a couple of ways that you can imagine improving this. Like the signature doesn't really say which is which.
Yeah, item 1, item 2. If you leave the feature like that, I will not use it.
You will not?
No.
Okay. Well, we'll improve on it then. So one thing that we do want to do, but I don't have in the prototype yet, is we want to allow you to immediately deconstruct a tuple coming back. So declare 2 variables and get those 2 values into each their own variable with each their own name right off the bat. I can't show you that yet. But the other thing we want to do is that sometimes you do want to dot in, but you want better names. So let's give them better names, right? Let's give them names here, sum and count. And what you yeah. Well, I see. Are you for real there? All right. So I gave them names. You see, it's still not an error to call item 1 because that's the name of the underlying field in the sort of real IL. But if I press dot, we've hidden that from IntelliSense, and we're suggesting the better names for you. So you can now say sum here and count here instead. And all of a sudden, it's not so bad, right? That's actually pretty good. And now I've expressed my intent as I return from the method, which is which, first name, middle name, last name, which order do they come in. You have a name for it, and you can use that name to consume it on the other side. So that should be very nice. And again, these names are sort of, they're like parameters in a way. They don't mean so much semantically. They're sort of there to help guide you, but the underlying type is the same. So you see this tuple here has no names, but it's still perfectly convertible to the sum and count tuple here. And in general, as long as the types and arity match up, we're fine. OK, let's implement this method for real. So I'm going to, instead of returning 0, 0, I'm going to return r. And what is r? Well, that's 0, 0. But I am now going to take this tuple variable and use it as an accumulator. So OK, it also has item 1, item 2. So let's give it some names. Another syntax for names is sort of like you can name arguments. You can also name parameters. I'm going to give them different, or name tuple elements. I'm going to give them different names here. And so now this is a tuple of s, c, both ints. So now I can dot into it. And one way that I could, so I have s and c now. One way that I could do this is I could actually take advantage of the fact that tuples underneath, they're actually mutable. They actually just have fields, and they're just structs. Okay, so it's a very simple, no-nonsense, non-judgmental kind of thing. If you want to mutate it, fine. So I could actually go and say r.s plus equals something. Let's for each over the value, so we have something to plus with. For each v, var v, and values. Let's take this line up there, and I could just add v to it, to the s component of the tuple. And I can also take the result c and increment it here. So I actually get to write C++ today. So this is one way of doing it. This may not be to people's taste for this particular scenario, but it just shows that tuples are mutable. And if you want to mutate that third element, that's fine. You can do that. What I'll probably do instead is to take R as a whole and create a new tuple and assign it to it. So I'll just say the old tuple's s value plus v and the old tuple's c value plus 1, right? And now we made a nice updating the accumulator in one fell swoop. OK, with me so far? All right, yeah. OK, so that was essentially tuples. There are a few more things to note about them. One thing is, you may notice that this looks very much like a parameter list, okay? And that's not an accident. That's how we designed it. We wanted it to feel like when you put a tuple type in the return position, it should essentially feel symmetric to the parameter list, right? It feels like I am getting some things in and I'm sending some things out. Some things go in, some things go out, and it kind of looks symmetric. I kind of like how that feels, and I would always put names in my return tuples for this reason as well, like for the documentation and just the symmetry of it. Now, but they are a real type. This is a type expression, so I can actually use that type. For instance, I can use it as a type argument to some other generic type. So I could make it an async method, and this would be a way to return multiple values from an async method, which is kind of annoying today because async methods can't have out parameters, and out parameters are ugly anyway. So it's just a type like any other, right? Also, if you have, let's say you have things like a dictionary where you want multiple keys in your dictionary. You want to say the people who are 47 and their first name is George. You want to have a dictionary entry for those, right? So multiple keys, you can just use the tuple type as the key, because the equality and the get hash code and everything on tuples just works out for that. Okay, so it really permeates a lot of things. But I do think that the most common thing we'll see is tuples being just returned as multiple return values.
That's cool.
You like it?
I do. That's
Good.
really cool.
You're okay now?
Yeah.
Good.
I feel
and then when we get the deconstruction, it's going to be totally fine. All right. So enough about tuples. I think let's also talk a little bit about pattern matching. So let's make the example even a little more contrived. I want, instead of having these lists of ints, I want to have recursive lists, recursive arrays. So each element can either be an int or it can be another list that can contain ints and lists and so on down there. So I'm just going to do it the hacky way, where I'm just going to make an object array.
Ooh.
And yeah, it's nasty, right? But I don't have. They don't want to see me code the other thing. So
you're a terrible person.
I know. So I'm just going to make a recursive array here. So that means that I can't call my tally anymore because it expects an enumerable of int, but I can take an enumerable of object instead here. But now I can't. Of course, I can't add v to the accumulator anymore because it's no longer an int; it's an object. And the problem here, of course, is now I'm for eaching. Now I can expect two different things. I'm looking at an object, I don't know what it is, I have to test, is it an int, or is it an enumerable of object, or is it something else entirely? Okay, so how would I do that today? I would do something like if v is int, do that thing down there, and curly brace. But now I still can't add it, I still have to cast it as well. So I'm kind of like checking for, I'm checking that it's an int twice, which is annoying. So why don't I instead introduce a variable up here? As long as I'm already checking that it's an int, why don't I give it a name, right? So now in this expression, I can just ask, is it an int? And if so, call it I, and put that in scope. And then I can just use I here, and I'm only checking for it once, okay? Yeah?
You know, Matt, one of the things I've liked about the demos this year is that there really aren't any error squiggles.
Right?
It's a real working code.
This is, yeah, in that horribly hacked together prototype I have, with this extremely golden path that I'm taking. But okay, you know. Yeah, don't break the illusion. So, this, you can see this is just sort of like a nifty extension of the is operator, but it's actually there's a lot more going on here. So let me try to dig into that. So the thing you look at here, the int I in this position here, that's actually a new kind of thing we're adding to C#. It's a new kind of program element that we haven't had before that we call a pattern. Okay? So a pattern is something that, given a value coming in, it can test things about that value, and at the same time, it can extract information from it if that test succeeds. So this is a simple example of that, right? We're testing that it's an int, and we're extracting the int value from it if it is an int, and putting that in scope where that thing was true. So patterns can be used, and there are more kinds of patterns that you can imagine, and we'll see in a bit. So it's a new general concept. We're also not just adding patterns to the is expression, we're adding them elsewhere in the C# language. So, so to explore that part of it, let's imagine that now we want to write the code that deals with when there's another enumerable of object inside, right? So we could have another if here. If it wasn't that, then v is blah de blah enumerable. But as we start writing this out, we see that all of these become is tests over v. We're always checking something about v.
Yeah, that can get a little
and so it's
cumbersome.
Yeah, so it kind of starts to feel more like some kind of a switch, right? Where I'm looking at v and checking different things about it. So let's turn this into a switch statement instead. Make it a switch. Remove this line here.
You know, Mads, I think next time it's kind of required that you build refactorings to do these things. So
yeah, I probably should.
Let's go faster.
You can do that. Now, here's an interesting thing that I can do in a switch now. I can put patterns in my cases. Okay? So instead of just saying, you know, is v 7? Like, who cares if it's 7? I can ask, is it an int? And if so, put I in scope in that case and use that int. Okay? So again, this is another place where we're putting patterns. And in a sense, you can say that we're unifying is and switch, because now is can have all these kinds of patterns, including checking for constants that switch does, and switch can have all these patterns, including checking for types, which is what is does today. It's a unifying thing. The reason you see a red squiggle here is not because I'm lying. It's because I didn't put a break yet. Okay? You with me? Yeah?
I don't know. Oh,
So let's put that enumerable case in quickly. So if it's an enumerable object, let's call it L. Indent that correctly. What do we want to do in that case? Well, then we want to tally recursively the list that we just got. So let's say var t equals tally of that, of L. And then we can update R. Oh, let's see, R equals the old R value, R.S, plus the new tally's sum, OK? And the old count plus the new tally's count. All right? And then I have get the red squigglies. Give me a break. OK, so I got that done. But we can do more. OK, so we're inside of a switch statement. And there's a little more you can do with patterns in here. So let's say that I don't want to, if I have an empty list, I don't want to be bothered calling a recursive method on it. So let's actually make a separate case for when the list is empty. Let me take this case here and copy it, since I don't have a refactoring for it. And let's actually say that if I have an enumerable of object and there isn't anything in it, not any, then I just want to skip it and break. Okay? So you can put conditions in your switch case clauses as well. For instance, when they're coupled with patterns. But in general, we let you put conditions on there. And so this is only going to fire if it's empty. And then if it's not empty, we'll fall through and do the next one. OK? Yeah? Yeah. And of course, if let's say there's a null value in there, if we want to, let's make this null resilient, right? So we can, of course, still use constants. It's still an ordinary switch. So I can still use a constant. I can say, if there's a null, let's also just fall through here and skip through. All the usual switch stuff is still there. I can still fall through. I can still test against constants. I can still have a default, but I'm not going to write it here, and so on. It's just an ordinary switch, except now you can test for more things. All right? So that's another place where patterns show up. We're also thinking about adding an expression form of the switch. We're calling it the match expression, where it's got a lot more compact syntax. The cases will be expressions instead of statements, and the result of the whole thing is whichever branch you pick. But we don't have that yet. And then I said there were more kinds of patterns. So we've essentially seen the type check, and we've seen the constants that are already there from the is. We're also thinking about doing patterns that are recursive, that once you checked that it's, let's go and have a look. So here we have some people, some students and some professors. Some of the students have grades. Some of them are so new that they don't have any yet, Casey.
Oh, my grades are better than they were.
And here's an example of an is expression that checks for a more complex pattern. This is a more complex pattern. It has what we call a property pattern in it. So I'm checking that it's a professor. And when I've checked that it's a professor, I dive into it, and I check that the first name of the professor is Scott. And I look at I apply a pattern to the subject as well. But this is a pattern that won't actually put any restrictions on it. It will just introduce a new variable and capture that s, that subject, into that variable if all the other conditions in the pattern were true. OK, so now I have introduced s in scope. And in here, I know that it was a professor who was called Scott. And I can write out the subject. Now, when you start looking at recursive patterns, it's a little more daunting. And we'll prototype this, send out prototypes, and kind of get a feel for, is this like one step too far? Do people want to do it more sort of step by step themselves? But give us feedback on that when it comes out. I personally think it's sort of nifty.
I think it's cool. What I really like about these features in particular, and in the language design team, we've been just kind of agonizing over them and trying to make them as good as we can. And they're really starting to feel like they are integrated as part of C#. They don't feel like things that just kind of get bolted on, like, oh, we need to add tuples, so now here's the tuple part of the language, but it's fully integrated in the language. It becomes part of your daily toolbox. That's really cool.
I mean, many of you will know that tuples and pattern matching, I mean, they're not things that we came up with, right? They're in other languages, in functional languages in particular, like F# or Scala, whatever. You'll find these mechanisms already. But it's important for us that even as we harvest the usability of them, the usefulness of them, we want them to feel like part of C#. We don't want to feel them like there's some bolted on other language that you can switch over to inside of C#. So that's why we insist on this deep integration with the existing is expression, the existing switch, and so on.
Nice.
All right. I have one small thing to show, which is what I almost accidentally did in the beginning.
Yeah.
Because I started in the wrong place in the code, which is local functions. Okay, so many modern languages and some not so modern, and some of the first languages that were ever made share the ability to declare a function inside of another function. We've never had that in C# really. We have lambdas, but they're sort of a roundabout way of doing it.
Oh, okay.
And so I'm going to take this helper method here. I'm going to declare that it's a helper method for the main method, and I'm just going to stick it inside of the main method, like that. All right? And you see, it's remarkable how few squiggles I get. I get one because it's called static, and you don't have static methods inside of other methods. But other than that, I just declared a method inside of another method, and it's fine. Right? Now it's just in scope inside of that method. Nobody else can use it. If that's what you want, then that's actually great.
You have one squiggle. What is that?
Do I have a squiggle?
You do.
Let's go
At
and
the
have
bottom.
a look.
T.
At the bottom.
Oh, is it because it's
It's because there are two T's. Is that it?
Ah, yes.
Yeah. Yeah, I have a T in the enclosing scope as well. Yeah.
Yeah.
Oh well. But the reason why it's complaining about that is it actually matters that I have a T in the enclosing scope. So it gives me an opportunity to say that, of course, things that are declared in the enclosing function are in scope in the inner function, right? And so in those cases where you have to write a helper method, you pull it out, and you have to send all these parameters along with it that were just things that were in scope in the caller. Now you can just not pass those at all. Like just write that function and be able to see those locals just in your enclosing scope.
That's cool. That's
Just
almost
like you
like
can with Lambda.
It's almost like you planned that as part of the demo, just right there.
Yeah, right?
Awesome. Yeah.
Yeah, I totally shouldn't have given away that it was a mistake. All right, so and of course local functions, yeah, good for little helper functions maybe. Some people actually like to code in a way where they extensively nest functions. Again, functional languages, sometimes they encourage you to just have functions within functions. JavaScript is often written like that, and you can say many things about JavaScript, but hey, that can be a pretty good way of structuring your code. So if you kind of like that style, now you can do that in C#, at the risk of people having to get used to reading your code, of course. OK, so that's it for the language features I'm going to show. I'll return briefly here. You saw all that. Let's project again. We're also considering some other features we already implemented that just like you can have ref parameters, you can have ref returns and ref locals. Mostly good for if you have like arrays of structs or like very performance critical memory allocation averse environments like game programming or something like that. But it's useful to have. We're also thinking about a record feature that abbreviates some very simple declarations as writing value-like classes with all kinds of functionality on them. May not make it into C#7. We're thinking about allowing you to create immutable objects with object initializers. So we're making the world better for immutable objects. Again, something that may not make it. When you do have immutable objects, it would be really cool if you could sort of mutate them by creating a new one that's almost like the old one, and you're just sort of specifying the delta. And so we're also looking at how we can support a feature like that. But that may be for the further future. We'll see how far we get.
Yeah.
All right. And now Dustin is on top here.
OK.
Over to Dustin and his demo.
All right, let's go ahead and switch over. So I want to talk again about this inner loop, which is what we think about how we kind of describe the activities that you do over and over in the editor. There are many inner loops in an IDE like Visual Studio or Xamarin Studio, right? Where there's the kind of the debug compile loop where you edit, debug, compile. There are loops you do in ALM tooling and all sorts of things. But we really think about this editing inner loop where we want to make that experience as good as possible. And to be honest, that experience what people expect to be there in an editor, the bar has kind of gone up over the years on what's just expected to be baseline. If it's not there, you're not really in the game. Okay? And so we're looking at a number of those things. And we're also looking at taking a number of those things as we do those and making sure that they work both cross-platform in other IDEs, with Xamarin Studio, Visual Studio Code, and also in Visual Studio Code through projects like OmniSharp, which is a community-driven project that uses Roslyn to kind of create a little language server that sits on your machine, and you can query it for language service operations, like what would the completions be here to fill on a completion list, that sort of thing. And so I want to give you a sense of what we're doing in VS Code. So I've got installed here on this machine. This is my Mac. I grabbed the latest .NET command line tools from .NET Core off of github.com/.net/CLI. I literally grabbed the latest ones yesterday because I like to have potential points of failure because they make you secretly happy when they fail. You guys are awful, by the way. I can't believe that. So I'm going to create a .NET Core app just very quickly here. So we're going to do kind of the cheesy one. We'll do Hello World. And because I'm using super hot bits right now, the actual project I'm going to build, the bits it needs, the libraries it needs, aren't available on the primary NuGet feed. So I'm going to actually copy in just a custom NuGet config file in there so it knows how to get it. There's not really much to that. Just whoops. Just so you know, there's nothing really all that fishy. It just points to our myget feed. Okay. And so that's all that's here. We'll say .NET New to create a new C# project. And again, there's not a lot in here. Okay, 3 files. So I'm going to load this up in Visual Studio Code. And as it loads, certain things happen. First, it goes off and it loads up OmniSharp. It also brings in a project lock JSON that happens when it went off and did a .NET restore automatically for me when I pulled this up. And so it created a lock JSON. And also, you can see now that squiggles go away. It says at the very, very top, and it's kind of hard to see, it says required assets to build and debug are missing from your project. You want to add them. And so I say yes. And it adds a couple of files in my folder that help VS Code know how to launch this under a debugger, under a core CLR debugger on OS X, and also a tasks JSON that gives me a build task, just a basic build task that drives the .NET build. So now I can come in here and I can write some code. This stuff is built on again, it's built on OmniSharp, which uses Roslyn. So all this stuff works like I want it to, except for all caps. All right. So I can put some bits in here, add a property, we'll call it name, and down here I can create a new person. And you see IntelliSense is working like you would expect it to. We'll say it's you.
Oh, you're spelling it wrong on purpose.
I'm not spelling it wrong, am I? Did I spell it wrong?
You spelled my first name wrong.
Oh, yeah.
Well, or maybe you didn't.
Maybe I didn't. All right. So, but all I did was .NET New, fire up code, click yes on something, and start coding. And I press F5, it builds, and if everything works out all right, once I tell it it's OK to, it should, lo and behold, actually hit a breakpoint in the core CLR debugger. So this is all built on .NET Core right now, and this is app local running on my machine. So that's pretty cool. I can step and see everything work. And you can see these values update up here. So that's the sort of thing we're doing in VS Code. And again, this is sort of just taking that inner loop experience and trying to take it to other places other than inside Visual Studio, other than inside bigger IDEs like Xamarin Studio. Let's bring them into editors where you're writing C#, like in Notepad++, those sorts of editors. All right. So I'm done with my Mac. Let's go over to Parallels. I also want to point out that we shipped that C# extension for Visual Studio Code about 6 weeks ago, and it rose to the top quite quickly, and so it is now the most popular extension, which is good. It shows that when you download, an editor like Visual Studio Code on a Mac, still there are at least 150,000, folks that wanted to download this thing and try it out. So that's exciting. Okay, but let's flip over to Visual Studio. Now, in Visual Studio, I've got Visual Studio bits here that are super hot. Like I've kept this VM on ice for a little while now because I don't want to touch it. There are lots of little bits that came together to make this one work. But it also has a lot of features in it that we're going to be delivering in Visual Studio 15. This has got our, not 2015, Visual Studio quote-unquote 15, the preview, because that's not confusing at all. Right? We do that every time just to make you mad. Okay. So, for example, I've got some bits on here that do things like this, where it's highlighting in the IntelliSense list the things that you type, right? Which is nice when I want to do camel case matches, things like that, and I can see, right here that it's highlighting and showing me exactly what matched, right? Just kind of like little nice productivity things. What's also nice is it's kind of a MADS defeating system in the sense that, sometimes I use IntelliSense, sometimes I use it often I use it to help me type code faster, right? I'm hitting tab or I'm pressing space and committing the next thing. But also, I use it to explore things. I use it to explore APIs. I press dot and I look at an API to find out what's there and what's usable. And I say it was kind of a MADS defeating system because when we added extension methods, I no longer have any idea what is an instance method on an array anymore, right? And so if you look at the very bottom, very bottom down here, bottom of the screen, we've now added filter buttons. So when you're in this mode where you want to explore something and explore its members and see what's there, you can now filter those down. So I can say, well, just show me the members, or the methods, right? Or show me the properties and the methods, or just the properties. And I can explore an API and get a better sense of things.
Now I feel better about adding all those extension methods back then.
Yeah, you should. They're great, Matt, really. Sorry. OK. Now, how many people use the add using feature where you press Control dot? I'm not actually looking for a show of hands, but I know everybody uses this, where you get into a muscle memory situation where you press Control dot and add that using up at the top. And then when you press Control dot, you hate us when it doesn't show the, to add the using because you typed it a little bit wrong, right? You have to. That's the thing. It's unforgiving. You have to type it exactly right, or it won't show up, right? So if I want to type something like this, well, let's see what happens. Nothing. Too far off. So now, with the next version of Visual Studio, actually, sorry, this isn't an update. This is an update 2 for Visual Studio 2015, the one that's released, not the one that we're putting out next. In this version, I've typed that identifier wrong, and what you see here is that it's running a spell check algorithm that will offer to go ahead and run BitLocker.
How did you do that?
That's a new feature. We'll
that's
drag
incredibly
that
inconvenient.
We'll just ignore that. All right. I've kept this VM on ice for a while, like I said. But it will actually it will fix the identifier in the editor, fix my spelling mistake, and add the using for me, right? Which is awesome. Now, likewise, also in Visual Studio 2015 Update 2, we took that a little further, right? Now, over here in my solution, I have a project down here. It's called Super Helpful Helper Library. All right. And in my console app that I'm writing in right now, there's no reference to that, right? But there's a person class in there that I know it's there and I want to use it, and I think there's a reference. And then I go to type it and add using. Nothing helps me get that in there. So now if I type, say, person, I misspell it even, it'll come up and it'll say, hey, would you like to add a reference to that project and add a using and help me fix my spelling mistake? That's kind of awesome.
Yeah, can you actually just write the rest of the method for me?
Yeah, right. I can just write the rest of the method. All right. Now, something else we've done as part of this, just kind of taking it to the next step. Now, those are both actually available today. Those are in Visual Studio 2015 Update 2 that was released a few weeks ago. But also in this something we're working on is also the ability to take it even a step further, where something that I don't have, like a NuGet package, and ensuring that that is also available to go and add a NuGet package. And we've done all the work to make sure that, yeah, I don't have a project config or a project JSON in this project, but it will add one for me, and it does all the work to make the undo work for that. So if I accidentally click the wrong thing and it goes in and adds a NuGet package, I can get back, roll back to my original state if I make a mistake. Cool. All right. Next, I want to take a look. Actually, we're getting kind of low on time. There's a number of features I'd like to look at over in another instance of Visual Studio over here. Just very, very quickly, I'd like to mention, go to implementation. This is a feature that, if I have a big code base like this, and I want to find all of the, all the places where an interface is implemented. It's a daunting task in Visual Studio. You can either use final references, which gives me a giant flat list of everything available, right? So I can do that, and it shows me a big list of everything and all the places where it's used, which doesn't really, I mean, the actual implementations are there somewhere, but it's not that helpful. Likewise, I can come over to the Solution Explorer. I can click and expand and show derived types, and that actually gives me what I want, but it's super inconvenient and takes me out of the editor. So in update 1, we actually added a feature called Go to Implementation, which was like Find All References, but just found you either the implementations of interfaces or the overrides of an abstract or virtual member, those sorts of things. But we didn't give it a keyboard shortcut because we're mean-spirited people. So in update 2, the keyboard shortcut is Control F12, and so I can press that and get implementations now. Okay? That is in Visual Studio 2015 Update 2 as well. Now, something else we're playing around with, this is something that Casey's going to talk a little bit about tomorrow in our Roslyn talk, but the idea of also taking our analysis story around squiggles and fixes and really taking that, ratcheting that up a notch, up to really into the area of code style. Right? So a lot of us have different code styles that we want to maintain in a project. You can see I've got a whole bunch of squiggles in this one, and that's because I have set some code styles that don't match this code. Now, there are a few styles in here. So for example, I like to say that my fields and properties I like to access with this. This project didn't do that, so I'll turn that off because that's what it's doing. It's enforcing that for me and saying, hey, you said you prefer this, but that's not what appears here. And you see now those squiggles all go away. Right? So we're investigating and looking at and taking this a little bit further in the area of kind of code style and maintaining that, and also the ability to have that configured in an asset that you can carry along with your project. So that's something we're working on right now. Casey will show a little bit more tomorrow in her Roslyn talk. And something else we've been looking at now. I'm going to be honest. Usually when I talk to folks about C# language, and we get a lot of different requests, but almost on a weekly basis we get one request, which is all around iNotify property changed, right? You guys have all probably come up to somebody and asked for it yourselves. It's you know, the numbers would seem to indicate that. It's this thing where people say, hey, you know, it's so simple, isn't it? I mean, you guys are smart, and the compiler's smart. Couldn't we just do something like write something like this and just sort of make that work? And, well, I mean, maybe. So I'm going to, I press Control dot, and I find out that there's lots of things that do, in fact, use that. All sorts of NuGet packages that, in fact, that actually, declare a type called this because it is, it is so prevalent. So I'm going to go ahead and I'm going to generate this class, and then I'm going to do some magic. I'm going to add a NuGet package. Now, with Roslyn, we had I'm going to call this build shenanigans. Let's see if this finds anything. You know what? It's probably not. So let's go to the cheater spot. Come on. Oh, it's not going to. All right. What's that? Wrong install? Oh, you're right. I was. Man. Gosh, this UI, right? All right. So. Here we go.
Yeah.
Okay, so I'm going to add a NuGet package. Now, with Roslyn, we introduced the idea of a code-aware library, which was a library that could carry along static analysis to run your source code. Something that would run on the build server, it would run on the IDE, and it would produce diagnostics, right? Errors or warnings, squiggles that would show up in the IDE. But this is something a little bit more magical. So I'm going to go ahead and I've installed that package. I'll go ahead and build. And now, I come up here. Now, person here, it's just a partial class. It's got 2 properties. But if I come over here, now build's finished, and I dot into it, I see something really interesting. I see property changed. Ooh. Right? Ooh. Right, all I did was add that attribute. So let's see if this works. See what's happening here. Call it on property changed.
That's crazy, Dustin. Where did it come from?
I have no idea. Maybe it came in that NuGet package. Let's change the name though. If I want the property to actually change, I need to change some properties. So we'll call this. We'll change your name to me.
Oh.
Yeah.
Oh well.
I'm changing the last name too. All right.
You want my job as well?
Yes. Okay. So let's go ahead and launch this and see if it actually hits.
In which case, it will throw an exception.
Well, no, I've set a breakpoint there.
Oh, you set a breakpoint.
I did, and it did hit here.
Ooh.
What's going on? right? And so if I go ahead and look at the call stack and actually get in here, what's happened is we've introduced a kind of a, this is magical, and it's something we're playing around with, okay? So it's not for sure, okay? I'm just teasing you a little bit. But it's an idea of a source generator, something that also performs that similar static analysis to what a diagnostic analyzer would do. But instead of producing diagnostics, it produces new source code for the compilation. So it can respond to any sort of source code pattern. I happen to look at attributes in my source code. But this is giving you a whole Roslyn object model of your source code. So it could be anything in your source code. You'd be looking for all sorts of different patterns of code that you might want to generate on. And also in here is a hidden language feature that we're also playing around with. And there are two special keywords here, replace and original. Okay? And what these are, these are kind of a way of indicating that we want to wrap the previous member. If you noticed earlier, this person class is actually a partial class, right? And so this is another partial type that it generated. And these members can sort of sideways override, if you will, or wrap a member that it's binding to. So the compiler will bind to this new member, and then that's indicated with the replace keyword, and then you can use the original keyword to refer to the old one, right? And this gives a really great, useful way, and also kind of generally useful way to kind of do this sort of source code generation and introduce new behaviors. So, cool.
Yeah, very cool.
Yeah.
So we're running low on time here. If you can switch us back to the last slide here. So if you're interested in what we talked about, we don't have time to take questions in here, but we'll right after this we'll rush out to the Xamarin Microsoft booth area right outside here, and we'll take questions for as long as you come.
Yeah.
Tomorrow, as Dustin mentioned, Casey Uhlenhuth, where are you, Casey?
She's over there, right there.
She'll have a talk about Roslyn analyzers, including some new things we're doing there. Go play with the Visual Studio 15 preview that Dustin and I both showed things that are in. And watch out for prototypes and give us feedback on them when they come. All right, thank you very much.